my name's Richard Haynes. I'm co-founder of eTool. It's a WA organisation. We do life cycle assessment of the built form, and including buildings and infrastructure. Just a little bit of context on what I'm going to talk about today. When we look at global greenhouse gas emissions, at eTool we believe this is a really big problem. We've looked at that. Turns out 35% of it relates to the built form. And when you break that down a little bit further, it's around about 10% in embodied impacts. So the materials, transportation of the materials, construction and the maintenance of the building. And then the energy inputs, your electricity, gas, etc., around about 25%. So that's 11% of global greenhouse gas emissions relating to materials or embodied impacts, and 25% relating to energy inputs into buildings. So why do we want to lower the carbon footprint of our developments? There might be an environmental motivation. We know that 20 to 30% of species are at a high risk of extinction due to global warming. It might be around food security. We might be motivated by food security. This graph here, recently we've had some pretty extreme weather events in North America. Grain prices have gone up by around about 100% on average, pretty huge increases. It could be a humanitarian motivation. We're seeing more and more extreme weather events, more and more climate refugees, not so much from sea level rise at the moment. It's usually been driven by floods, but arguably linked to climate change, and certainly it will be in the future. The next biggest motivator that we've come across is probably costs. Okay, so you can imagine if you look 5 years ago or 6 years ago on this graph, something that may have been purely sustainable or purely motivated by sustainability is now probably got a really strong economic argument just because of the way this is residential electricity prices on this graph. And that same trend in energy prices is pretty much across most of our major energy sources. This is oil. This has actually had a 300% increase rather than 100% increase like electricity. And the other thing that I'd like everybody here to focus on today is because if you don't do this, you're going to be left behind, okay? This is happening all over the world. The world recognises that we need to move to low carbon economy, and it's happening. This is a 50,000 person or occupant city in United Arab Emirates. It's already in construction, and it's going to be 100% run on renewable energy. So it'll be operational energy neutral. That last slide there is a smaller community in Germany. This community generates way more power than they need at the actual development, and it's mainly solar power, but they also have some renewable biomass combustion as well. This is a proposal in the UK. This is 80 dwellings, similar sort of net zero energy. This is actually the Vatican, and the Vatican, so even the Pope's on board with this. Closer to home, this is Cape Patterson in Victoria. These guys are looking to develop a zero carbon development, and I'll talk about the costs. I've already talked about the costs. These guys did a massive study on what they needed to do to deliver zero carbon dwellings, and they found that the average cost or average return on investment for these sustainability measures was around about 12%. So less than 10-year payoff, quite amazing. Closer to home, we saw a picture of this development pop up in Alex's talk, saw my thunder a little bit there. This is Stevens Street in White Gum Valley, fantastic development. We did a life cycle assessment for these guys. They're actually our first client. And this is definitely operational energy carbon, if not net zero carbon, including materials as well. And the one I'm going to profile today is the Green Swing. This is just south of the river, and it's a townhouse development. So, as I said, you will be left behind if you don't move in this direction. So basically, the business as usual in Perth, acres and acres and acres of project homes, okay? We know through life cycle assessments that these homes are responsible for approximately 4 tonnes of CO2 emissions per person per annum, so per occupant per annum. If we break that down and have a look at the embodied carbon and the operational carbon, and this is what life cycle assessment's all about, is actually identifying where the problem is and then reducing the impacts. So approximately 30% embodied carbon and 70% operational carbon. And if we look at that in more granularity, we can see that the biggest single thing there is actually materials, okay? It's bigger than thermal control, it's bigger than your heating and cooling, bigger than your hot water, bigger than your entertainment. So let's look at the biggest thing we can do to actually reduce that. So the Green Swing, one of the best things they've done to increase that, and we've also heard about density, was increase the density. So why is density important? More than 90% of houses are knocked down for redevelopment or other reasons. Now these stats are really hard to find, but there's two quite well-constructed studies. This one here is a North American study. 85% of buildings in this study were knocked down due to redevelopment. Only 6% actually reached the end of their useful life. So we've got all these wonderful BCA codes, and none of our buildings actually require it because they're all knocked over before the buildings reaches the end of its service life. This is an Australian study, similar sort of results. So only 8% become unserviceable, and that would probably be even less if we maintain those buildings properly as well. We also want to future-proof it. So think of not only what the current occupants are going to want with that building, but the future occupants as well. How have we enabled that building to evolve over time to remain applicable? What's it going to look like in 10, 20 or 50 years' time? So just by changing the density of their building, they were able to reduce the materials impact by around about half. So it was an 11% reduction in the overall carbon emissions of the project. They also reduced the floor size, and this is floor size per occupant. They reduced it by about 35%, but by providing community amenity within that small development, they were able to maintain the functionality of the living space. So that was another 3% reduction in the overall footprint of the building. And we know over the last 20 years that housing size has increased by 40%, yet we've got 10% less people in our houses or in each dwelling. So a 35% reduction is actually not even rewinding 20 years, but we've increased the other amenities in the development. Improved material selection, we were able to shave another 2% off by going for light frame construction where we could. Straw bale walls were slightly better. Not a huge amount, we're talking about 3 tonne saving, which you'll see isn't massive in the scheme of things. They actually got more savings to just going from natural finishes, so moving away from more maintenance intensive finishes to natural finishes that will last longer, won't require repainting, etc. And then replacing standard concrete with blast furnace slag concrete, for example, was another 4 tonne saving. And then we move on to the operational energy. Okay, so we've really been focusing on the materials up until this point. We moved to the operational energy. They were able to achieve a 43% saving in the carbon emissions of the building by focusing on energy efficiency. How did they do that? Hot water was the biggest single item there, 85 tonne saving. Energy metering, another 81 tonne saving. They don't have a pool and spa, so that's 28 tonne saving on average across dwellings in Australia. Lights, another 46 tonne saving in CO2. Using natural gas for cooking purposes in preference to electricity. Much better use of primary energy rather than burning the coal hundreds of kilometres away and transporting it and losing all that energy in the process. They were able to save nearly 30 tonnes from moving the house from 6.5 star or 6 star through to 9 star. And that takes them down to the point where they need to actually start generating their own power to finish things off. So a 1.7 kilowatt system at this point is going to bring that building down to operational energy neutral. And if they've actually gone a step further in this development and said, well, we're going to feed enough energy into the grid and offset that carbon intensive energy and we're going to end up reducing our total footprint to 0. with their solar system. What was actually required for that was a 2.5 kilowatt system, but they put a 3 kilowatt system on there. So they've ended up with a net zero carbon building in life cycle terms. Pretty incredible thing when you just focus on it at the end of the picture, but when you look at how they've done it, it's actually quite achievable. And that's basically ends my talk. I guess we'll have some time for some questions. Excellent. So yeah, we've got an opportunity to reduce global greenhouse gas emissions by 35% if we replicated this across all dwellings. Now, we're still a ways away from that, but if we're not doing it in 20 years, we will be the last people not doing it, I think.